Hello everyone, I am Kushal SJ of Electronics and Communication Department staying in Bangalore Institute of Technology. Today I am going to discuss about circular linked list in C programming. Here I will explain linked list and their types. Firstly, what is a linked list? A linked list in data structure that stores a sequence of elements. Each element in the list is called a node and each node has a reference to the next node in the list. The first node in the list is called as the head and the last node in the list is called as the tail. Here we can see the reference to the next node in this list. Basically, there are four types of linked list: singly linked list, doubly linked list, circular singly linked list, circular doubly linked list. Firstly, what is singly linked list? It's the simplest type of linked list in which every node contains some data and a pointer to the next node of same data type. The other one is doubly linked list. A doubly linked list or a two-way linked list is a more complex type of linked list that contains a pointer to the next as well as the previous node in sequence. The third one is the circular linked list. A circular linked list is that in which the last node contains the pointer to the first node of the list. Doubly circular linked list. It's a more complex type of data structure in which a node contains pointer to its previous node as well as the node. Here we will discuss about the circular list briefly. A circular linked list is that in which the last node contains the pointer to the first node of the list. As we can see here, the last node contains the address of the first node. We traverse the circular singly linked list until we reach the same node where we started. The circular singly list has no beginning or end. No null value is present in the next part of any of the nodes. There are two types of circular list. One is circular singly list, the other one is circular doubly linked list. It is similar to singly linked list except that last node of circular singly list points to the first node. Here we can see the last node of the circular singly list points to the first node. Circular doubly linked list. It is similar to the doubly linked list except that last node of circular doubly linked list points to the first node and the first node of the circular doubly linked list points to the last node. Here we can see that the last node points to the first node and the first node points to the last node of the circular doubly linked list. How we can implement circular list? A circular list can be used as a stacker queue. To implement this data structure, we require the following 5 functions. The following 5 functions are insert at front, insert at rear, delete at front, delete at rear, and display. Insert at front means to insert an element at the front end of the list, whereas insert at rear means to insert an element at the rear end of the list. Delete front, to delete an element from the front end of the list. Delete at rear is similar to delete at front. It means delete an element at the rear end of the list. Finally, we have to display. Display is used to display the contents of the list. Let us know about inserting a node at the front end. To design the function easily, let us consider a list with 4 nodes. Here, variable last contains the address of the last node of the list. Here we can see the 4 nodes 1, 2, 3 and 4. This is the last node. Obtain a node using getNode function and copy item into field as shown below. Temp getNode, temp is equal to getNode. Here we create a new node to insert. After executing the above statement, assuming the item is 50, the linked list can be written as shown below. Here, the temp node is the new node to be inserted at the front end of the circular singly linked list. In the step 2, we have to copy the address of the first node into link field of temp. This is possible if list is existing. The code for this can be written as follows. If last is null, make temp itself as the last node. Now the above code can be modified as shown below. If last is not equal to null, temp link is equal to last link, else temp is equal to last. After executing the above code, the list can be written as shown below. In the step 2, we have to copy the address of first node to the link field of the temp node. In the third step, we have to make temp as first node. This is possible by copying temp into link field of last node as shown below. Here we have to make this temp as the first node. This can be done by copying this temp into last link field of the last node. We have to copy the address, we have to copy this temp to the link field of the last node. Then finally at the fourth step, we return the address of the last node using the statement return last. The list as seen calling function is shown below. Here the temp is inserted at the front end of the circular singly linked list, and its address is obtained by the last node. Let us move on to inserting a node at the rear end. To design the function easily, let us consider a list with 4 nodes. Here the variable last contains the address of the last node of the list. Here we have 4 nodes. It is the last node. In step 1, we have to obtain a node using getNode function and copy item into field as shown below. Temp is equal to getNode. It means here we are creating a new node to insert. After executing the above statement, assuming the item is 50, the linked list can be written as follows. We have to insert this new node temp at the rear end of the circular singly linked list. We have to insert this node at the rear end. In step 2, we have to copy the address of the first node into link field of temp. This is possible if list is existing. The code for this can be written as if last is not equal to null, temp link is equal to last link. If last is null, make temp itself as the last node. The above code can be modified as shown below. After executing the above code, the list can be written as shown below. The address of the first node is copied into the link field of temp. In step 3, we have to make temp as the last node. This is possibly by copying temp into link field of last node as shown below. Last link is equal to temp. Now the list can be written as shown below. We have to make this temp node as the last node. This can be done by copying this temp into link field of the last node. Finally, at step 4, we return the address of the last node using the statement return temp. The list as seen from the code is shown below. Here the new node temp is inserted at the rear end of the circular singly list, and it is considered as the last node. Here we are going to differentiate between the function to insert an item at the front end of the list and the rear end of the list. This is the function signature node. Here node is a type representing a node in the circular linked list. Here item is an integer value to be inserted into the new node. The function returns a pointer to the last node in the list after insertion. Last is a pointer to the last node in the circular linked list. This is the body function. Node temp is the variable declaration where temp is a pointer to a new node that will be created and inserted. Temp is equal to get node. Here we are creating a new node. Then if last is equal to null, here we are checking for an empty list. If last is equal to null, it means the linked list is empty. Then we have to insert the new node at the front end. At last, we have to link the last node to the first node. Return last. It means the function returns last node. The major difference between function to insert an item at the front end of the list and the rear end of the list is, here we are going to insert a new node at the front end. Here we are going to insert a new node at the rear end. Here the function returns the last node. Here the function returns the new node as the last node. This is the major difference between these two. Let us jump on to deleting a node from the front end. Design. When an item is deleted from the list, the various cases to be considered are: list is empty, list containing one element, list containing more than one element. The sequence of steps to be followed to delete an element from the front end of the list can be written as shown below. In step 1, obtain the address of the first node. The code for this can be written as shown below. First is equal to last link. The list after executing the above statement is shown below. Here we have to obtain the address of the first node. Then we have to copy this to the link field of the last node. Make second node as first node. We have to make this node as the first node. This is obtained by copying first link to last link. This can be done by copying the link field of first to link field of last. The code can be written as shown below. Last link is equal to first link. Thus first node is isolated and second node becomes the first node. The list after executing is shown below. Here the first node becomes isolated and the second node becomes the first node. Remove the first node. We have to remove this node. The first node in the list can be removed using free function. But before removing the node, display the appropriate message. The code for this case can be written as shown below. Printf, print the function the item deleted. Free, delete the first node. Free first means here we delete the first node. After executing the above code, the list can be written as shown below. Here we are removing the first node at the front end, at the front. Then this node becomes as the first node. The final list as seen from the calling function can be written as shown below. Here we can see the final seen from the calling function. Here a node at the front can be removed. This node is removed at the front end. This is the final linked list. Let us examine the function to delete an item from the front end. Function signature: node delete, node last. Here node is a type of representing node in the circular linked list. Last is a pointer to the last node in the circular linked list. Function of the body: it's the variable declaration. First is a pointer to the first node in the list, which will be used later. If last is equal to null, it checks for the empty list. If last is null, it means the list is if last is null, it means the list is empty. We have to print this function return and returns null. As there is empty linked list, we should return null. If last link is equal to last, this condition is used to check for a single node in the list. If last link is equal to last, it indicates the list has only one node. The function prints the item deleted followed by the info of the last node. The last node is then freed using free. The function returns null as the list is now empty. Here first is equal to last link. Obtain node node to be deleted. Last link is equal to first link. Stores new first node in link of last. The function frees the first node. It means deletes the first node and return last. It returns the last node. Return always address of last node. Finally, we have to display the circular singly linked list. The displaying circular singly linked list contains the content of the circular singly linked list. The C function to display the contents of the circular list is shown below. The reader is required to understand how the function is working. Here void display is the function signature. Last is the pointer to the last node in the circular linked list. Node is a type representing a node in the circular linked list. The function returns void, meaning it does not return any value. This is the function. This is the body of the function. It's the variable declaration. Temp is a pointer to a node in the list which will be used to traverse the list. If last is equal to null, this condition is used to check for an empty list. If last is null, then we have to print the function list is empty and return. Then we have to display the message. It prints a message indicating that the contents of the list will be displayed. Here we have to initialize temp to the first node. Traverse here we have to traverse the list and print each nodes while loop continues as long as temp is not equal to last. Inside the loop, info field of the current node pointed by temp is printed. Temp is then updated to point to the next node in the list. Print the last node's value. After exiting the loop, temp points to the last node. Then info field of the last node is printed, followed by a new line. By this, we can understand the function to display the contents of circular list. At last, I will provide some uses and advantages of circular singly linked list. It is used for memory utilization. Circular list can be more memory efficient for certain applications, avoiding the overhead of managing head and tail pointers separately. Efficient traversal. Circular list allow for efficient traversal, particularly useful in application requiring round-robin scheduling or continuous iteration without the need for resetting pointers. Ease of insertion or deletion. Inserting or deleting elements in a circular list can be more straightforward compared to linear list, especially when dealing with queues or buffers. However, circular lists also come with challenges such as more complex implementation and potential difficulties in debugging due to their non-linear nature. Thank you.